Tell us your name and tell us about your project.
Okay, hello. My name is Sir Arthur Eddington, and in the 19th century, me and several of my colleagues, we wanted to prove Einstein's theory of general relativity. Actually, I am at a young 30 years old. I'm very famous for my work concerning the theory of relativity. And my interest in the theory of relativity became after William Day Sitter passed his notes onto me in 1916. I wrote many articles announcing and explaining his theory, and everyone around the global world became more interested, and the press kind of exploded with many different stories and about Einstein and my experiment supporting his theory.
Cool. What were you guys trying to find?
The main thing we were trying to find or prove is basically just try and find an experiment to prove Einstein's theory of general relativity. And we ended up finding that bending the light around, huge objects is known as gravitational lensing and would become an important subject in astrophysics. And a lot of these astrophysics now use gravitational lensing to try and understand the universe and dark matter.
Cool. Where did this project take place?
There were two different locations. One location being a remote island called Principe, and another being Sobral, Brazil. So first we measured the true positions of the stars during January and February of 1919, and then we traveled to these remote islands to measure the star's position during the solar eclipse, which was kind of a huge thing in the project. And we wanted to do two different positions to make sure that the clouds or other outside problems may occur. So that's why we had two different places. And back then we did not have our we do not have global communication like you will have in the future, and we don't have transoceanic airplanes. So traveling was not an easy feat. And, we had to do it right now because solar eclipses only happen every 18 months or so. So it was kind of a once in a, it was very important that we did it while we can, and it took us a very long time to travel, by boat to these, remote locations.
What other significant events were happening around the world at that time?
Well, there were several crazy events going on. One being on June 4th, women's rights. The United States Congress approved the 19th Amendment in the United States Constitution, which allowed them to vote and would guarantee suffrage to women, which was big. Another thing, on September 3rd, Jan Smuts actually became the second Prime Minister of South Africa. And on March 4th, the Communist International is founded, or the Comintern.
Who else was involved in the project?
There were several people who were, integral in this project. Most specifically, Sir Frank Watson-Dian, who was an astronomer, Royal of Britain, came up with the idea for the experiment in 1917. And he came up with the idea of the total solar eclipse and us utilizing that to help with the experiment. And someone else, Dyson, he was the one who realized that the stars would have to pass through the sun's gravitational field on its way to Earth. And then another person, Andrew Crommelin, who was an astronomer at the Royal Greenwich Observatory. And he was like my co-manager or administrator per se, and he helped me kind of schedule these different events and help us with the traveling and whatnot. And also Newton and Sauter were also involved in the experiment because they helped with different findings through different papers that they wrote, which was very important.
What was your role in the project?
My role was, as you maybe say, like the manager. I kind of helped put it all together with traveling expenses, and we actually got a grant, federal grant, to help with the expenses mainly. So I kind of helped coordinate all of these different things, and I did a lot of data analysis as well. And I released a paper a year later regarding this experiment, and it was kind of widely known that it was kind of poor evidence and it wasn't very good. But later on, they actually did find out more evidence saying that my calculations were very efficient and supported Einstein's theory of general relativity very well.
What impact did your project have on the physics community?
Well, it had a big impact. When we returned from England, our data from the island of Principe confirmed Einstein's predictions and his general theory of relativity. And on November 6th of 1919, I announced all of his findings. And then shortly after that, Einstein was kind of a huge success, and he was on the front page of all the newspapers, and everyone was really fully into the idea of general relativity, and it proved him to be a genius. And this experiment really helped him out with his career and everything.
Where did you get the inspiration to conduct such an experiment?
Well, I've always been fascinated with the stars and the universe and space and whatnot, and astronomy. And I actually started my higher education quite young, at the age of 16, at the University of Manchester, and that was in 1898. I studied mathematics and English literature. I spent the first year in many general courses, but then ended up majoring in physics for the remaining of my 3 years. I eventually graduated in 1902 with a bachelor's in physics, and I continued to higher education at Trinity College in the University of Cambridge, and I received my master's, and I would continue to secure a position at the Royal Observatory in Greenwich, where I kind of embarked with my career in astronomy and obtained the fundamental ideas for this experiment. And later on, during World War I was actually the secretary of the Royal Astronomical Society, where I received a series of letters and papers from William de Sitter regarding, his notes on Einstein's theory of general relativity. And, like I mentioned earlier, it was kind of like this time where my wheels began to turn on this experiment, and I was starting to gain some traction with different, people. So, thank you.